Let us go ahead and learn how to subtract rational expressions. I'm going to introduce you to rational expressions, give you an example or two, and then we're going to talk about the steps that are required for you to subtract rational expressions, and then we'll do some examples together applying those steps. A rational expression is a fraction that has a polynomial in its numerator and its denominator, and a good example of that would be x squared minus 3x plus 2 divided by 4x to the 5th power. That's an example. So now how do we go ahead to subtract? How do we go ahead and subtract these rational expressions? The first thing we're going to do is find the least common denominator for the denominators of these rational expressions. Then we'll go ahead and rewrite each rational expressions with this new least common denominator as its new denominator. We'll subtract the numerators. We're going to go left. We're going to go left to right. So we're going to subtract the items on the right from the ones on the left, and then we're going to simplify whatever expression we get. So let's go ahead and apply this to some examples. So we're going to start by looking for the least common denominator for x minus 3 and then x squared plus 2x minus 15. So this is x minus 3. So this is x minus 3 to the power of 1. And then we have x squared plus 2x minus 15. This is going to be the same as x minus 3 to the power of 1 and then x plus 5 to the power of 1. So our least common denominator is going to be x minus 3 to the power of 1 multiplied by x plus 5 to the power of 1. So the next step we're going to follow is I'm going to actually rewrite each of these so that each of these denominators using their factors where necessary. So I have 7x over x minus 3 minus 5 over x plus 2 and then x minus 3, sorry. So this is going to be x minus 3 and then x plus 5. So now we're going to go ahead and rewrite this so that they have the same denominator. So this is going to be 7x, we're going to multiply by x plus 5 over x minus 3, and then we have x plus 5 minus 5. It's already the denominator we desire, so we just multiply by 1 over x minus 3, and then we have x plus 5. So now let's go ahead and simplify. So we have 7x squared plus 35x minus 5 over x minus 3 and then x plus 5. So this is going to be the answer to the problem that we have to work through. Let's go over to the next question. So we're going to first find the least common denominator. So we have x minus 1, which is equal to x minus 1 to the power of 1. Then we have x squared plus x minus 1. This is actually, you cannot factor this without using the quadratic formula, which we're not going to use here. So this is going to be x squared plus x minus 1 to the power of 1. And so the least common denominator is going to be x minus 1 multiplied by x squared plus x minus 1. And so this is our least common denominator. So let's go ahead and try to rewrite each of these so that we have a common denominator. So we have x over x minus 1. We're going to multiply this here by x squared plus x minus 1. Multiply also x minus 1 minus 5. And we have, right here, we already have x squared plus x minus 1. We're going to multiply by x minus 1, numerator and denominator. So now let's go ahead and simplify. So this is going to be x cubed plus x squared minus x. This is going to have a common denominator. We have a common denominator of x squared plus x minus 1 multiplied by x minus 1. So this is minus 5x plus 5. So this is going to be x cubed plus x squared minus x minus 5x is going to be minus 6x and then plus 5 divided by x squared plus x minus 1 multiplied by x minus 1. So that is going to be the answer that we're going to use here. And then finally, we're going to try to solve this. X squared minus 4 is the same as x plus 2 to the power of 1 multiplied by x minus 2 to the power of 1. And then we have x squared minus x minus 2 is going to be x minus 2 multiplied by x plus 1 all to the power of 1. So your least common denominator is going to be x plus 2, x minus 2, and then x plus 1. So now we go ahead and simplify this right here. We're going to rewrite each of these with a new common denominator. So we have, but before we do that, let's go ahead and rewrite each of these denominators as their just replace them with the factors. So this is going to be 2x over x plus 2, x minus 2, minus x plus 1 over x minus 2, x plus 1. So this is going to give us, look at our least common denominator. We have x plus 2, x minus 2, so we need x plus 1. So 2x multiplied by x plus 1 over x plus 2, x minus 2, x plus 1 minus x plus 1, so we have x minus 2, x plus 1, so we need x plus 2, minus x plus 1, and then x plus 2 over x plus 2, x minus 2, and then x plus 1. So now we'll go ahead and go through the process of simplifying. So we have 2x squared, which is from here, and then we have plus 2x, and then I'm going to put a minus here, and then I'm going to open up a parenthesis and simplify these. This is going to give us a quadratic. I'm going to simplify that in the parenthesis because the negative sign is going to apply to whatever is the product of these two binomials. So this is going to be x squared plus x plus 2x plus 2, and then this is over x plus 2, x minus 2, and then x plus 1. So we'll keep simplifying. So we have 2x squared plus 2x minus x squared. This is x plus 2x is 3x, so this is going to be minus 3x, which is, we get that from this right here, and then minus 2. And then this is over x plus 2, x minus 2, and then x plus 1. So we'll keep simplifying. So this is going to give us 2x squared minus x squared. So that's going to give us x squared. 2x minus 3x. This is minus x, and then minus 2. This is over x plus 2, x minus 2, and then x plus 1. So let's go ahead and simplify this. This is going to give us x minus 2 multiplied by x plus 1 over x plus 2 multiplied by x minus 2 multiplied by x plus 1. And now we can cross out common terms. So x minus 2, we have a common term down here. X plus 1, we have a common term down here. So this is going to be 1 over x plus 2.